Hello students, in our previous class we learned about quadratic polynomial. That means its zeros and the relationship between the zeros and the coefficient of x square, x and the constant. Okay. So in this class we will learn how we can solve a quadratic polynomial when its zeros are given. So here we choose three problems. They are problem 1, problem 2, and problem 3. Okay. So in problem 1, it is given that alpha and beta are the zeros of this quadratic polynomial f of x equals to x square minus 5x plus 4. We have to find the value of 1 by alpha plus 1 by beta minus 2 alpha beta. Okay. So let us study how we can find the value of this 1 by alpha plus 1 by beta minus 2 alpha beta. Solution 1. The given quadratic polynomial is f of x equals to x square minus 5x plus 4. Comparing the above polynomial with the general form of quadratic polynomial f of x equals to ax square plus bx plus c, we get a equals to 1, b equals to minus 5, c equals to 4. Since f of x equals to x square minus 5x plus 4 imply f of x equals to 1 into x square plus minus 5 into x plus 4. Okay. So a is equals to 1, b is minus 5 and c is 4. Since alpha and beta are the zeros of the given quadratic polynomial, therefore alpha plus beta is equals to minus b by a, imply alpha plus beta is equals to minus of minus 5 by 1, imply alpha plus beta is equals to 5, and alpha into beta equals to c by a, imply alpha into beta equals to c means 4 and a means 1. So alpha into beta is equals to 4. Okay. Already we learned sum of the zeros is equals to minus b by a and product of the zeros is equals to c by a. So by this relation we find alpha plus beta is equals to 5 and alpha into beta is equals to 4. Okay. Now 1 by alpha plus 1 by beta minus 2 alpha beta is equals to, first of all we have to add these two terms by the LCM by after finding the LCM of these two denominators, that is the LCM of these two denominators alpha and beta is alpha beta. So after adding these two, we get alpha beta as the denominator and beta plus alpha as the numerator, and this thing 2 alpha beta will remain same. Now we can put alpha plus beta is equals to 5 and alpha into beta is equals to 4. So this becomes 5 by 4 minus 2 into 4. So this will give 5 by 4 minus 8. Now there is no denominator, means 1 is the denominator. The LCM between 4 and 1 is 4. So this is 5 minus 8 into 4, that is 32. So this will give minus 27 by 4. So this is the way by which we can find the value of 1 by alpha plus 1 by beta minus 2 alpha beta. Okay. In problem number 2, alpha and beta are the two zeros of this polynomial. F of x is equals to 3x square minus 6x plus 4. We have to find a polynomial whose zeros are 2 alpha by beta and 2 beta by alpha. Okay. So before finding the polynomial whose zeros are 2 alpha by beta and 2 beta by alpha, first of all we have to find alpha plus beta and alpha into beta from the given quadratic polynomial. Solution 2. Given quadratic polynomial is f of x equals to 3x square minus 6x plus 4. Comparing the above polynomial with the general form of quadratic polynomial f of x equals to ax square plus bx plus c, we get a equals to 3, b equals to minus 6, c equals to 4. Since we can write the given polynomial f of x equals to 3x square minus 6x plus 4 as okay. So a is 3, b is minus 6 and c becomes 4. Since alpha and beta are the zeros of the given quadratic polynomial, therefore alpha plus beta is equals to minus b by a, imply alpha plus beta is equals to minus of b means minus 6, a means 3. This will give 6 by 3. imply alpha plus beta is equals to 2 and alpha into beta equals to C by A is equals to 4 by 3. Now, 2 alpha by beta plus 2 beta by alpha equals to, here the LCM of the denominator beta and alpha is alpha beta. So in the denominator we have alpha beta, and in the numerator it will be 2 alpha square plus 2 beta square. If we taking 2 as a common factor, then this will be twice of alpha square plus beta square. That means 2 into alpha square plus beta square whole divided by alpha beta. Now we can apply the identity of a square plus b square. Since by the identity p square plus q square is equals to p plus q whole square minus 2pq. Already we know this identity, that is p square plus q square is equals to p plus q whole square minus 2pq. So by applying this identity, we can write twice of alpha square plus beta square as 2 into whole into alpha plus beta whole square minus 2 alpha beta. Okay, so why we use this identity p square plus q square equals to p plus q whole square minus 2pq, because here we have alpha plus beta and alpha into beta. Okay, so alpha plus beta means 2. So this will give 2 square minus 2 into alpha into beta means 4 by 3 whole divided by 4 by 3. 12 minus 8 by 3. So sum of the zeros, that is 2 alpha by beta plus 2 beta by alpha will give 2, and 2 alpha by beta into 2 beta by alpha will give 4 alpha beta by alpha beta. Cancelling this alpha beta, we from numerator and denominator we get 4. So therefore the required quadratic polynomial equals to g of x is equals to some non-zero constant k into x square minus sum of the zeros, that is 2 alpha by beta plus 2 beta by alpha into x plus product of the zeros, that is 2 alpha by beta into 2 beta by alpha, where k is a non-zero constant. Okay. So this imply g of x equals to k into x square minus sum of the zeros, that is 2 alpha by beta plus 2 beta by alpha is 2. So 2x plus and this product is 4. Okay. So this is our required polynomial. That means when when a quadratic polynomial and its two zeros are given, then when we have to find a quadratic polynomial which has two different zeros, then by this way we can find that quadratic polynomial. Okay. So we already done problem 1, problem 2. These two problems are two different problems. In the first problem, we have to find the value of 1 by alpha plus 1 by beta minus 2 alpha beta when when the zeros of a quadratic polynomial are alpha and beta. Okay, and in the second problem, we find a different kind of quadratic polynomial whose zeros are not given directly. That means first of all, to find its zeros, first of all we have to find alpha plus beta from the given quadratic polynomial and alpha into beta. Okay, and the rest of the procedure is already I showed to you. Okay, in problem 3 is a different kind of problem. So in problem 3, there is a relationship between the zeros of a quadratic polynomial. Okay. So with the help of that relationship, we have to find an unknown quantity. That is, the condition is that if the squared difference, squared, what do you mean by squared difference? Squared difference means square of the difference. Okay. So if the squared difference of the zeros of a quadratic polynomial f of x equals to x square minus px plus 45 equals to 144, then find p. That means here this is p. So this p is unknown. So we have to find the value of p by this condition. Okay. So to find the value of p, first of all we have to let the zeros of this quadratic polynomial. So let the zeros of the quadratic polynomial f of x equals to x square plus px plus 45 be alpha and beta. Okay. So now comparing the above quadratic polynomial with the general form of quadratic polynomial f of x equals to ax square plus bx plus c, we get a equals to 1, b equals to p, c equals to 45. Since f of x equals to x square plus px plus 45 imply f of x equals to 1 into x square plus px plus 45. Okay. So therefore, alpha plus beta is equals to minus b by a, imply alpha plus beta is equals to minus p by 1, that is alpha plus beta is equals to minus p, and alpha into beta equals to c by a, imply alpha into beta equals to 45 by 1, imply alpha into beta equals to 45. Okay. So first of all, we let alpha and beta are the zeros of this quadratic polynomial, and after letting this, we compare the given polynomial f of x equals to x square plus 5x plus 45 with the general form of quadratic polynomial f of x equals to x square plus bx plus c. We get a equals to 1, b equals to p, and c equals to 45. Then alpha plus beta becomes minus p, and alpha into beta becomes 45. Okay. Now, by the problem, according to the problem, the square difference of the zeros. Square difference means square of the difference. So here the zeros are alpha and beta. So square of the difference means their difference becomes alpha minus beta, and square of this difference means alpha minus beta whole square. So square difference is 144. Since square difference of the zeros means square of the difference square of the difference between the zeros. Okay. So that is why we have alpha minus beta whole square equals to 144. Again, we have y minus z whole square is equals to y plus z whole square minus 4yz. This is an identity. With the we can use this identity here, because already we know alpha plus beta and alpha into beta. That is why if we apply this identity, then we get alpha plus beta whole square minus 4 alpha beta is equals to 144. Alpha plus beta means minus p. So minus p whole square minus 4 into alpha into beta means 45 is equals to 144. This will give p square minus 180 equals to 144. This will give p square equals to 144 plus 180. This will give p square equals to 324. So P is equals to plus minus 18. Okay. So this is the way by which we can find the value of P. That is, we use this condition, and the condition is that the square difference between the zeros is 144, and by that condition we can write alpha minus beta whole square is equals to 144, and then we can apply this identity, that is y minus z whole square is equals to y plus z whole square minus 4yz. And after applying this identity, we can put the value of alpha plus beta and alpha into beta. And after putting this value, we get p squared is equals to 324. And then p is equals to square root of 324. Square root of 324 is plus minus 18. Thus, we can find the value of p. Okay. So in this class, we learn about three quadratic polynomial problems, and these three problems are different from each other. Okay. So the FD topics are very much clear to all of you. Okay. So in our next class, we will learn about the cubic polynomial and their properties. Okay.